Okay, we're here with our student Luke looking at the distributive property together. Ready to go?
Yeah.
Okay, first let's talk about distributing. This is one of the most important skills you can have in algebra, so let's remind ourselves how it works. Okay, I've taken an expression 3 times 4 plus 2 in parentheses, or we say the quantity 4 plus 2. And I've written it twice here because we're going to do it once with order of operations and once with the distributive property to make sure that the distributive property actually works, okay?
Okay.
All right, so with order of operations, what would you do here first?
4 plus 2.
Good, and why do you do that first?
Because it's in parentheses.
Okay, and what is 4 plus 2?
6.
So could I write it like this?
Yeah.
Okay, good. And then what's that 3 doing to the 6?
Multiplying.
So what's 3 times 6?
18.
18, excellent. So we know that this expression here could be simplified to be just 18. Now let's try the distributive property over here and see if it also comes out to be 18.
Okay.
Okay, and remember with distributing, what we're doing is we're going to take that 3 and we're going to distribute it to the 4, and we're going to distribute it to the 2. I'm going to write some arrows here to show that. So that we're going to multiply that 3 times the 4, and then we're also going to multiply that 3 times the plus 2. Okay?
Okay.
So we can rewrite it like this. Does that look right?
Yeah.
Okay. And then what is 3 times 4?
12.
And what's 3 times 2?
6.
So we have 12 plus 6. And what is 12 plus 6?
18.
All right, excellent. So our two different methods, using our order of operations and using distributive property, came up with the same answer, right?
Yeah.
Okay, let's try another example that's a little bit tricky, and we'll see why in a second. So let's use our order of operations to simplify this expression here. What would we do first?
5 minus 3.
Which equals?
2.
So can I write it like that?
Yeah.
Okay, good. And then what is 2 times 2?
4.
Okay, so we know this thing has to equal 4. Let's go ahead and look at it using the distributive property, okay? So what should I write next?
2 times 5.
Good, and then what else?
Minus 2 times 3.
Very good. 2 times 5 minus 2 times 3. And the tricky part there was that minus. So if we have a minus sign there, don't forget that there's going to have to be a minus. Some people would write this as 2 times 5 plus 2 times a negative 3. Just either way is fine, but just make sure you don't lose that negative, okay?
Okay.
And what is 2 times 5?
10.
And what's 2 times 3?
6.
So can I rewrite that like that?
Yeah.
And what's 10 minus 6?
4.
Excellent. So once again, what we've done is we've found the same answer by using the distributive property. Now you might say, that's so silly. Why don't I just do it over here? Why do I have to go to all this distributive property nonsense when I can just use my order of operations? Well, the answer is that sometimes this is important because you'll be working with variables. For instance, let's look at this one. We have 2 times the quantity b plus 7. Well, we can't just add b plus 7 with our order of operations, right?
Yeah.
Okay, so now we use our distributive property. How would you write that? What would you do?
2b plus 2 times 7.
And what is 2 times 7?
14.
So 2b plus 14, does that make sense?
Yeah.
Okay, let's try another one. What would you write here? 3 times the quantity 6x minus 5. How would you write the answer to that?
18x minus 15.
Good, because you're multiplying that 3 times the 6x, which is 18x, and then you're multiplying that 3 times the minus 5, which is minus 15, right?
Yeah.
And it even works with fractions. So here we have 1/5 times the quantity 30x minus 35. Wow, that looks a little hairy. But what's 1/5 of 30x?
6x.
6x. And what's 1/5 of negative 35?
Negative 7.
Good. So can I rewrite that as 6x minus 7?
Yeah.
Outstanding. Excellent. So the distributive property really helps you with variables. Now let's talk about what is kind of like the opposite of the distributive property, which is factoring, okay? So let's take this example that we have right here, 2b plus 14, and we know it's the same as 2 times b plus 7. So let's look at that as an example, okay? We know that 2b plus 14 is the same as 2 times the quantity b plus 7, right?
Yeah.
Okay, but what if instead of being given this right here in distributing, we were given this and we were trying to move to this form? What we'd want to do is we'd want to look to find something that we can factor out of both of these terms here. We want to look for the greatest common factor. So what's the greatest common factor of 2b and 14?
2.
2, right? Because 2 divides into 2b and 2 divides into 14.
Yeah.
So then what we can do is we can take that GCF, the greatest common factor, we can bring it outside the parentheses, And then we just ask ourselves what's left inside. Well, to make 2b, we would just need a b there. And to make the 14, what would we need?
7.
7. So we can get to this form, 2 times the quantity b plus 7, by using that GCF. Make sense?
Yeah.
Okay, so let's do another example really quick here. So we have 12y minus 32. So what's the greatest common factor of 12y and 32?
4.
4, right? Okay, you could do 2, because 2 goes into both of them, but that's not the greatest common factor. It's just a common factor, right?
Yeah.
Okay, so the GCF is 4. So now what should I write? What would be the first thing you would write?
You would write 12. Yeah, you would write 4.
Good. You'd write 4, and then what would you write?
12y. Or 3y.
Good, because you're factoring that 4 out of the 12y, yeah?
Yeah, and then minus 32.
Would you write minus 32, or would you factor that 4 out?
Oh, you would write minus 8 then.
Good, excellent. So what you have here is you've taken that 4 and you've pulled it out of each term. So if I factor 4 out of 12y, I'm left with 3y. And if I factor 4 out of minus 32, I have minus 8. And just like you say, you write the 4, then the parentheses, and then the 3y minus 8. Does that make sense?
Yeah.
Okay, you're good to go. Great job.